Picture the global automotive landscape just a short time ago. The consensus was overwhelming, almost echoing in unison across every major market. The era of the internal combustion engine was over, finished, relegated to the history books. Everyone, from policymakers to industry giants, believed with absolute certainty that the future belonged exclusively to electric vehicles and the massive batteries that powered them. The petrol engine was viewed as a dinosaur, slowly and inevitably fading into extinction. But beneath the surface of this supposedly settled debate, a shockwave was brewing. BYD, a company many mistakenly viewed purely as an EV champion, made a move that has fundamentally shaken the entire automotive world. They started talking about a new, highly advanced turbo-boxer engine. On the surface, to the casual observer, this might just seem like a routine technology update, another engine in a world full of them. But if you look closely at the engineering philosophy and the timing behind it, this isn't just a new piece of metal under the hood. It is a calculated, strategic game changer. Because suddenly, the question we should be asking is no longer which is better, electric or petrol. The real question, the one keeping executives at legacy automakers awake at night, is this: can a perfectly engineered system emerge that takes the absolute best of both worlds, eliminates their respective weaknesses, and completely rewrites the rules of the game? The industry is already buzzing with speculation. Is this specific engine designed to directly target the glaring, often ignored weaknesses of pure electric vehicles? Could this combination of technology finally provide the ultimate solution to the paralyzing challenges of range anxiety, charging infrastructure bottlenecks, and astronomical battery costs? And if it does, will the current battery-obsessed EV market suddenly seem incredibly outdated? To understand what is happening, we have to look at the technology BYD has actually deployed here and why it is positioned to dictate the future of human transport. What you are about to discover might force you to look at the cars on the road today from a completely different perspective. To view BYD as just an electric vehicle manufacturer is to see only half of the battlefield. The undeniable truth is that they are not just betting the farm on electric cars. Their goal is far more ambitious: total dominance of the global auto market. While they are setting records selling pure EVs, they have been pushing plug-in hybrids with the exact same ferocious intensity. Every new engine they design isn't just a mechanical component, it is a tactical chess move. If we look at the raw sales data over the past few years, a fascinating picture emerges. In 2023, BYD moved nearly 3 million vehicles. Almost exactly half of those were pure EVs, and the other half were plug-in hybrids. Moving into 2024, that total ballooned to roughly 3.5 million vehicles, and the ratio held strong. Hybrids were not a secondary thought. They were performing right alongside pure EVs. This data reveals a massive truth. The company is not building a future totally dependent on giant lithium-ion batteries. They are building an adaptable hybrid ecosystem. And this is precisely where the new turbo-boxer engine enters the spotlight. We need to clear something up right away. This is not the traditional fuel-hungry petrol engine you grew up with. The old internal combustion engine had one brutal, simplistic job: explode fuel to forcefully propel the heavy vehicle forward. It meant more noise, massive heat loss, and high fuel consumption. But this new vision completely redefines the engine's job description. In this new paradigm, the engine doesn't just drive the wheels, it acts as a highly efficient support mechanism. It functions as an onboard generator that dramatically reduces the load on the battery, exponentially increases the vehicle's driving range, and crucially balances the massive costs associated with building purely electric systems. This is what a true, uncompromised hybrid future looks like. Let's be incredibly honest about the state of electric vehicles today. Despite the hype, the three massive elephants in the room remain: agonizing charging times, crippling battery replacement costs, and the terrifying reality of long-distance range anxiety. Driving an EV in a wealthy, hyper-developed city center is a dream. It is seamless and quiet. But step outside that bubble and the reality fractures. The charging network is simply not robust enough to support mass adoption in every country, every rural town, and every long stretch of highway. In this fractured reality, the advanced hybrid engine serves as the ultimate bridge. It is a technological compromise that perfectly balances the urgent needs of today with the zero-emission dreams of tomorrow. So why a turbo boxer engine? Why not a standard inline-4 or a V6? To understand the brilliance of this, you have to understand the mechanical poetry of the boxer design. In most cars on the road, the cylinders inside the engine are arranged either standing straight up in a line or angled in a V shape. A boxer engine lays those cylinders completely flat. The pistons are positioned opposite each other, punching outwards and inwards simultaneously, exactly like two boxers tapping their gloves together before a fight. The primary, unparalleled advantage of this flat design is perfect natural balance. When one piston fires and pushes out, the opposite piston does the exact same thing in the other direction. The forces physically cancel each other out. This drastically reduces the violent vibrations that normally tear through a car's chassis. The result is an engine that runs with silky smoothness, making the entire vehicle feel planted, premium, and incredibly stable. But when you attach a turbocharger to this naturally balanced setup, the rules of physics seem to bend. A turbocharger's entire purpose is to force-feed an engine, allowing a tiny power plant to punch way above its weight class. It captures the wasted energy from the hot exhaust gases spinning out the back of the engine and uses it to violently compress fresh air into the cylinders. More compressed air means you can burn fuel more efficiently, creating a massive surge of power from a very small footprint. You essentially get the raw power of a heavy V6 engine with the fuel-sipping efficiency of a tiny commuter car. It acts as a hidden reserve of explosive energy, unleashed seamlessly the millisecond your foot demands it. When you combine the inherent, vibration-free balance of the boxer with the dense power of a turbocharger, you get a masterpiece of efficiency. It is whisper quiet when cruising, yet fiercely capable when merging onto a highway. This leads to the realization of why this is so dangerous to the pure EV market. Is this engine explicitly designed to kill electric cars? Directly, no. But indirectly, it systematically dismantles the EV's greatest vulnerability: absolute dependency. A pure electric vehicle is entirely at the mercy of its battery chemistry and the external grid. If the battery is dead, the car is a 2-ton paperweight. But a smart hybrid system beautifully balances the battery with this hyper-efficient engine. It means that if global battery technology hits a plateau, or if the global rollout of fast charging infrastructure stalls due to economic or political hurdles, the driver never actually suffers. They remain completely independent. Not every market on Earth operates like California or Shenzhen. A pure EV might be the logical choice for a commuter in a hyper-modern metropolis, but it is deeply impractical for someone traversing the vast distances of emerging markets in South America, Africa, or rural Asia. By perfecting both EVs and these advanced hybrids, the message being sent to the world is clear. The future of transportation isn't a single, narrow path. It is a multi-lane highway. Let's dig deeper into why this compact nature of this turbo boxer is so vital. In modern automotive engineering, brute horsepower is no longer the ultimate metric. Space, weight, and aerodynamic efficiency are the new gods of car design. A massive, heavy engine ruins handling and consumes vast amounts of space. A tiny, potent turboboxer changes the geometry of the entire car. Because the boxer engine lays completely flat, it has an incredibly low profile. This allows engineers to mount it deep down at the very bottom of the engine bay. This drastically lowers the vehicle's center of gravity. Think of how a sports car hugs the road compared to a top-heavy SUV. By lowering that center of gravity, the car resists body roll. It corners sharper, feels more anchored to the tarmac at high speeds, and provides a driving dynamic where immense power and total control exist in perfect harmony. Furthermore, because it takes up so little room, engineers have maximum space to package the high-voltage batteries and electric motors required for the hybrid system without encroaching on passenger legroom or widening the car to absurd proportions. To fully appreciate why this hybrid approach is surging back into the limelight, we have to expose the hidden, often unspoken weaknesses of the pure EV utopia. From the outside, the electric dream is flawless. Zero tailpipe emissions, no expensive trips to the gas station, and near silent operation. But look beneath the glossy marketing and the cracks are highly visible. Let's talk about the absolute luxury of time. In a traditional vehicle, you pull into a station, pump liquid energy for 4 minutes, and you are instantly granted another 400 miles of freedom. In an EV, that exact same task is an event that must be planned. Even with ultra-fast chargers, which are incredibly rare outside major corridors, you're looking at 30 to 45 minutes of waiting. If you're stuck with a standard charger, you're waiting hours. Long-distance road trips transform from spontaneous adventures into rigid, meticulously calculated logistical missions where your route is dictated not by the scenery, but by the availability of functioning power outlets. Then there is the financial reality of the battery itself. The massive lithium-ion pack sitting under the floorboards is the single most expensive component of an electric vehicle. It's why EVs, despite years of promises, still carry a premium price tag that locks out the average working-class buyer. While the tech is improving, the raw material costs stubbornly refuse to crash. And hovering over every EV owner's head is the eventual degradation of that battery. Replacing a degraded pack out of warranty can cost as much as buying a brand new economy car. This brings us to the geopolitical nightmare of rare earth metals. To build these massive batteries, the world needs incomprehensible amounts of lithium, cobalt, and nickel. These are not infinite resources, nor are they evenly distributed around the globe. The mining processes are complex, geographically concentrated, and highly vulnerable to supply chain shocks. If a geopolitical conflict chokes the supply of lithium, pure EV production grinds to a devastating halt and prices skyrocket overnight. And what happens when everyone actually plugs in? Grid pressure is a silent crisis brewing in the background. Imagine millions of commuters arriving home at 6 p.m. and simultaneously plugging their cars into a power grid that is already struggling to run air conditioners in the summer. Utility companies are quietly panicking about whether the aging electrical infrastructure of most nations can actually survive the load of a fully electrified society. This is where the battle for actual usable range is fought. It's not just about what a laboratory test claims a car can do on a single charge. It is about how far you can drive without anxiety creeping into your chest. Hybrid systems utterly neutralize this anxiety. A compact, incredibly efficient turboboxer engine acts as a safety net. It doesn't force you to rely on gasoline forever, but it guarantees that you will never be left stranded on a dark highway simply because a charging station was out of order. Range is not just a number on a dashboard. It is the psychological freedom to go wherever you want, whenever you want. We also need to shatter a massive myth currently dominating the automotive space: the truth about performance. Today, the internet is flooded with videos of electric family sedans violently out-accelerating million-dollar supercars. And it's true, electric motors deliver instant, terrifying torque. The millisecond you touch the pedal, 100% of the motor's power hits the tires. There is no waiting for an engine to breathe, no waiting for gears to drop. It is instantaneous violence. But performance is not just about the first 3 seconds off the line. True performance is about sustained, relentless power. How long can a vehicle maintain that output? In a pure EV, that instant torque is heavily taxed at high speeds. As you push an EV hard on a highway, the battery drains exponentially faster, and the system often limits power to prevent the electrical components from literally melting. This is where advanced turbo-hybrid systems rewrite the rules. They offer the exact same instant, off-the-line electric punch, completely eliminating turbo lag. But as the car reaches higher speeds and the electric motor begins to lose its breath, the turbocharged engine seamlessly takes over. It breathes deep, utilizes its mechanical advantage, and provides sustained high-speed power without instantly killing your driving range. If you're in gridlock city traffic, you glide silently on battery power. If you're blasting across a continental highway, the engine hums to life, providing endless, stable power. True performance is absolute reliability in every single driving condition, not just a parlor trick at a stoplight. This exact philosophy is why we must look at the giants who refuse to conform. When the EV gold rush began, legacy titans like Toyota were mercilessly mocked. The media narrative claimed they were dinosaurs, clinging to the past, destined to be crushed by Silicon Valley startups. Toyota refused to build all-electric fleets, stubbornly insisting that their hybrid strategy was the correct path. Many called it a massive corporate failure.